Alright, so I wanted to go over all of the topics that we went over in Minesweeper. Just some things that we practiced and some things that might have been interesting to some people. So here are the topics that I thought were of particular interest. Everything else was kind of just fiddling. So we're going to go through this one at a time. Processing a 1D array as a grid. Instead of having an array of 10 by 10, you could just make an array of 100. When x and y are known, accessing it is just this. Y times the width plus x is the same thing as x and y. If you want to practice, you can pause the video and use your finger to point at the screen to show yourself how this makes sense. If y is 2, that's where it will be. And then x is 3, that's where it'll be. Yeah, feel free to poke at your screen until that makes sense. I use this all the time. If you don't know x and y, while you're traversing the loop or something, you can use I to get them. I will be the inverse of this. Y will be I divided by width, and then your integer division will floor it. So you will not have a 1. You will not have any number other than 0 until you are actually at 1. Until 8 divided by 8 is 1. Until you get there, it's just going to be 0. And then x is I modulo width. If you don't know how modulo works, I would really look into that, play around with it. Traversing an array through loop looks like this. I'm sure you could figure that out, but using this picture, this graphic, try to figure out how this formula works. Just if you want to, pause the video and just figure it out. I could tell you how it works, but we're practicing. You should probably try to do it yourself. So why would you ever do this? Why would you make a 1D array when you can make a 2D array? I'm gonna be honest. A long time ago, somebody told me it was faster, and I was like, okay, and I just took their word for it. Before I was making this, or before I started recording this, I did look around on Google and stuff, and a lot of people did agree that it is faster, and I think the best answer I can find is that an array in C is a pointer to a first instance of the thing, where a two-dimensional array is 2 pointers, if that makes sense. And then they're all just, you have the whole thing right in front of you for 1 dimension, and then you need 2 different ones for a 2-dimensional one. Do your own research and decide whether or not this is worth it for you. Drawing a grid of lines. This one is easy, like after the first time you do it. Until the first time you do it, it's a little bit but the first time you do it onwards, it's dead simple. So drawing a grid of lines for each row, y stays the same but x changes. For each column, y changes but x stays the same. How do I make this line go this way to make a grid? How do I make this line go this way to make a grid? If you put these in a loop, you can have the loop counter change x for each column and y for each row. And then you just combine the two of these together and you will have this. One thing I did not account for in this is padding. If you wanted to put padding in here, and then you would obviously multiply by your gap. You would put your gap in there to offset your rows so they're not all on top of each other. How to draw a grid of squares. Given the last slide, how do you think we draw a grid of squares? Pause the video, try to think about it, draw it on a piece of paper, whatever you gotta do. Just a hint, really, to think about is this answer will change based on what kind of a draw square method you're using. Some of them do like top left corner, bottom right corner. Some of them do top left corner plus width plus height. Some of them do center x and y. I don't like that one, but that is a thing that happens. There we go, just so you can see it. I don't know why it didn't just make this wider, but anyway, one more hint. It also depends on how your grid is stored. For example, mine was a 1-dimensional array. In the next slide, I'm going to show you how I did it, but if you wanted to do that other type A or B.5, this is practice. We're practicing, so do it yourself. All right, pause the video, and then when you're ready, let's go. To draw an array of squares, assuming your grid, your loop counter is I, you're going to take padding plus I modulo column count times your rectangle width. This will be your x coordinate. Padding plus I divided by row count times rectangle height, and then the width and the height will be rectangle width and rectangle height. So assuming if 8x4 grid, this will produce this if you were to do that. So once I equals 8, x will reset to 0 because of modulo, y will be set to 1 because of integer division. We already went over that. Padding is also referred to as offset in some implementations. That is a very interesting thing to note, and I hope that you remember it, because if you have a toolbar on this side of the screen, over here, you wouldn't refer to this whole space across the whole span of the window as offset. I mean, as padding, you would probably call that offset because that's more apt of a term. So be aware of that. Padding is sometimes called offset. So in the above case, rectangle width and rectangle height are the same, which makes a square. This does not have to be true. Just remember that. You can have different sized things in there. So bit masking for state, this is something that I did that I didn't have to do, but I just thought it was interesting to do. So you're basically just turning an integer type into a bunch of different booleans, where a boolean is true or false. In a lot of languages, a bool will be represented by the smallest possible value, which is a byte, but you get 8 bits for just 1 bit of information. It's a waste. So what you could do instead is, if you have a lot of them, you could utilize all 8 bits in your byte to get 8 different boolean values. So I thought that was pretty cool. I'm having trouble finding the source, but as far as I can tell, actually, anecdotally, I've done this before. I've seen it. I think when you do bit manipulation with the bitwise operators, your value is promoted to a signed integer unless you cast it again. This is obvious with the not operator, because if I go from 1 and I not that, I'm going to get a negative 2 million or something. And it's just like, well, hang on, it's supposed to be an unsigned char. Why is it in the 2 millions? Because it was promoted to an integer. So here's how we represented our squares inside of the game. This looks like a lot of different things, but they're all flags. These are all just names for individual flags. This is one way of just doing a bunch of different booleans. And then this is a mask. This is how you would tell me, do I have any neighbors at all? You would AND that mask with the square that you're checking. And if it returns 0, this square has no neighbors at all. That's what that means. So we can now represent this entire thing with just 2 bytes. And you toggle these bits on and off using your bitwise operators. Like I mentioned before, it might be promoted to an integer anyway, so why mention that it's 2 bytes if an integer is 4 bytes? Well, it's promoted during comparison, not in storage. I can fit twice as many shorts into a cache line than ints. So, something to think about. Alright, so that's nice, but there is a caveat. Like I mentioned before, we're working on an integer type. We're just setting bits in an integer. If you take a bunch of bits and read on this value, you will get back a whole decimal number. So if I set these 2 flags here, and then I AND that back with some data into test, test is equal to this, so I have those 2 flags set, but if I were to just read that, that is equal to 96. That is not equal to 2, that's equal to 96. I made that mistake in the stream. Just don't make that mistake. One thing you can do to get around this, and this is one of my favorite things that I've learned recently, is that in C, conditionals evaluate 0 as false, otherwise true. So by doing AND on a single bit, you will either get back a 0, because it's false, it's not there, or something else, like 96. But who cares what it is because it's not 0. It's true. Isn't that fun? So using that information, how do I actually tell how many neighbors I have? Another fun thing about the result of a conditional is it is in fact always going to be 0 or 1. So non-zero values, this is the way that I've thought of it. Non-zero is always true, but true is always 1. What does that mean? If you take this and AND these two together, you're going to get, or let's do this one. You do these two, you're going to get like 96. But if you just check if that's greater than 0, this whole thing will evaluate to 0 or 1. So you catch all of these right here and then just sum them up. It's that easy. So that's something fun to think about. This might be undefined behavior, but as far as I can tell, everywhere I've tested it, it's pretty certain. So I don't know how undefined it is, but hey. Next thing that we're going to talk about is converting the client XY to the grid XY. Just for terminology's sake, this window is a Windows. I don't know why I have the Docker thing there. This Windows thing, it has like the title bar and stuff that just comes with Windows. Client X starts right here at the top left of File. It does not start here. It starts right here. This, everything from here to here, down here, is referred to as client space. They have a window space where it goes up into the title bar, but we're not talking about that. So, converting client XY to grid XY. I want you to tell me how to do it. Take a guess. As a hint, we have already done exactly the opposite. Alright, moving on. When we made our grid, we offset everything by padding, so we need to remove the padding, so we're going to get rid of this. And then you just divide by the rectangle dimensions of what you're checking. So for X, I'm going to be checking against width, and Y, I'm checking against height. But if I put my mouse right here, what we're going to do is we're going to subtract padding from the entire thing, and then just do what we did to draw the grid in reverse. We're going to take the width. The width, I think I said was 8. So we're going to 25. Rectangle width, not the grid width. So it's 25 pixels wide. Here's the answer. I want you to figure out why it works. So make a small little program that'll do this for you. I promise you will learn a lot. So here it is. This is a flood fill algorithm that we did. I do feel like, as I was watching the footage back, I do feel like I kind of glossed over this, but only because I had just done something very similar above, and I was like, great, cool, so I already explained this, but let's talk about it real quick. First of all, what this was is I found the implementation for this on Wikipedia like 3, 4, maybe even 5 years ago. No, way longer than that, 2017. So a long, long time ago. I found it there, and I implemented it in a game called Terminal, which was the command line thing that I stole from someone else. And I have not used it. I used it a couple times since then, but I have not looked at this Wikipedia article since then. Because once you realize the algorithm, once you kind of figure it out, and the tool that you're using, your programming language is no longer in your way, you can kind of just like, oh, I think I can do this, and then you'll be able to just bang it out. So I did the whole flood fill thing off of memory. I'm not at all saying that I'm smart. I'm saying that it is that easy, and then once you start to learn how algorithms work and how your language works, then you will just be able to do that again. So from where you start, branch out in all directions, 4 or 8-way. Eventually we wind up implementing the 8-way version. It's on the next slide. And you test your condition. If it passes, you fill it, whatever fill is, and then if it doesn't, you stop, and then you do not branch on this node anymore. So then it will kind of trickle backwards up until you get back to your main loop. So my implementation is the naive version where you check indiscriminately until the recursion ends. There are optimizations. Some people have found a way to check less. I don't remember, but there's optimizations to be had. Regardless, even without the optimizations, this was fine because it only happens when you click the mouse. This is not happening every frame. It might be worth investigating if you're doing something like this very often, but we're not, so we don't have to. So one more thing to be aware of is you need to check whether it's safe to test, otherwise you'll test out of bounds. So if you want to check y minus 1, you need to make sure that y is greater than 0, because y is 0 and you do -1. Your index you're checking is -1 in an array, which doesn't exist. So if you want to check y plus 1, you need to make sure that y is less than the bound -1 because of array indexing. So you don't want to go out of bounds, you want to stay within your bound. So here's the implementation. Like I said earlier, first of all, you can ignore this. This is just the way that I chose to do this. I just pulled this out of this data. I grabbed this and put it as like just a regular variable in the stack, so that way I don't have to keep going inside of my pointer to get it. But I had a stupid idea because I do that anyway, you know. So there it is again. If I find that this tile is checked, or it's bad, which is what I refer to as a bomb, or if it's flagged, because I let the user place a flag, and if they place a flag, I'm going to say, oh, okay, so you think this is a bomb, I'm going to treat it like a bomb. If it's any one of these three, just return immediately, do not do anything else. If it's not, then we're going to check it. We're going to set this to that dark gray color, and it's like an explored tile now. And then, once we check it, we're going to see something. This is not out in the video yet, but the neighbor mask. If this tile that we just checked has any neighbors, stop, return out. This is why, in the video that I just posted, the gameplay looks so shit, is because it's revealing too much information. Alright, but now this is the actual algorithm for the flood fill. If y is greater than 0, we're going to flood fill x y minus 1. So you're calling the flood fill function in all 8 directions around the tile that you're checking, recursively. So let's go back to here. If I check this one, can you see? Yeah. If I check this one right here, let's make this red. Yeah, okay. So if I check this one, I'm going to check up, this way, this way, this way, this way, this way, this way, and this way. So this one's, first of all, I'm going to check it. So check. And now I'm going to look at this one. This one will check. This one, this one, this one, and this one. And this one. And it'll see this one and go, no, that's not what I wanted to do. So it'll bounce back out. Put that back there. It'll bounce back out and it'll check this one. Oh, okay, so let's check that one. And then it'll check this one. Okay, let's check that one. Okay, let's check this way. Let's check that one. And so on. You're basically using this recursion to walk through every single tile. And this is one of those things that it's recursion based. It's really, really difficult for a lot of people to understand just because of that. And you're gonna have a bad time with it if this is your first time doing something like recursion, until you do it a couple of times and then you're just like, oh, okay, that makes sense. This is one that is definitely worth practicing. I would recommend you, the second this video is over, try to implement this, try to experiment with this, just work with this one because it's very cool and it's a very good practice for recursion. So you can check the description for the playlist that contains this and all of the videos related to the coding session where you can watch me do all of this. Feel free to leave any comments or suggestions in the description. It's been a long time since I've been on YouTube, so I'm still kind of trying to get the rust off, and this series is kind of just happening as it happens. I don't really have a plan yet, but hopefully something cool comes of it. If you have any suggestions or questions or anything like that, feel free to let me know. And don't forget to practice, god damn you. Take all the stuff that we talk about and implement your own version from scratch. Just tease these topics, figure them out, and that's how you become a better programmer.